online retail forecast for 2010 through 2015. So they predict that U.S. e-commerce is going to reach about $278 billion per year by 2015. They have discovered that about 5.5 billion new customers shopped online for the first time in 2010, and those new customers represented about 30% of annual online sales. And finally, they said that 83% of the folks that they talked to prefer to shop online instead of going to crowded stores during the Thanksgiving weekend. Next slide. Now let's take a look at some facts about the Thanksgiving and the holiday season. Typically, the day after Thanksgiving is known as Black Friday, when people begin to do their holiday shopping in earnest. So some reports have it that Thanksgiving and the holiday season generally accounts for about 60 to 65% of overall annual online sales. And as this holiday season kicks off, most e-commerce companies are going to see a spike of anywhere between 4 and 6 times the normal amount of traffic that they get. So the 2010 Black Friday had online sales of about $700 million, and that apparently represents the highest online spending in a single day. So it's really important when you start thinking about your website to make sure you're prepared to deal with this level of traffic. Now, as you start thinking about your website, it's really important to realize that that performance of your site is super important at this time. Surveys have shown that 78% of folks have gone to a competitor's site due to poor performance at peak times, and that a poor experience will often lead to less return visits, a less positive perception, and generally some negative information spread around about the site. So a poor web experience is going to impact your revenue, your brand, and your customer loyalty. So now let's focus in on something called the Amazon Web Services, or AWS. So AWS is our cloud computing offering. We're part of Amazon.com. And so the idea with AWS is we give you access to flexible, scalable, cost-effective infrastructure technology designed and applicable for businesses of all sizes located anywhere around the world. So AWS is a set of utility services. They're offered on a pay-as-you-go basis. You can launch individual servers, you can launch database services, and so forth. And the amount that you spend will be directly proportional to the amount of resources that you actually consume. So as you'll see later in this webinar, it's very easy to scale up and scale down in response to changing needs. And really important to note, when you're making use of the Amazon Web Services, you are taking advantage of all the knowledge, expertise, and tools that have been used to run Amazon.com's own global web properties for over a decade. Next slide. So we have a very, very broad line of services that altogether make up the AWS Compute Platform. This webinar is not the place for us to go into tremendous detail, so let me just give you a quick overview of some of the more fundamental services. We have services such as the Elastic Compute Cloud, or EC2, that allows you to launch servers on demand. When you launch these servers, you can choose from any one of 11 different sizes of machines, which we call instances, with varied amounts of CPU power, RAM, disk storage, and network performance. To these machines, you can attach virtual disk volumes that we call elastic block storage volumes. Each of those volumes can range in size from a gigabyte all the way up to a terabyte. These are virtual disk volumes. You can create and attach multiples of those to each of your compute instances. We also have a number of storage services, including the Simple Storage Service, or S3, for object-based storage in the cloud. Currently holds 449 billion objects and processes over 290,000 requests per second. We also have services for messaging, networking, content delivery. We have a number of development and management tools. We have a service called Elastic Beanstalk, so you can build an application, easily upload it to the cloud, and we'll automatically create all of the infrastructure for you. Development toolkits for Eclipse, and the visual management console to let you manage all of your resources. A number of database services, including the relational database service, to make it very easy to set up, scale, and operate a relational database such as MySQL or Oracle. And then automatic scaling services to make it easy to design and architect applications that will automatically scale up and scale down in response to load. So we'll talk a little bit more about a few of these in later parts of this presentation. Next slide. So one of the questions that comes up quite a bit when people hear about the cloud is they simply say, is it safe? What about security? And these are very, very common questions, and we've done our best to pursue a number of different certifications to make our security model as evident as possible to you. We have obtained ISO 27001, CES 70 Type 2, PCI DSS Level 1 certifications, among others. We publish a set of security white papers and also a risk and compliance papers with a lot of details about our physical and our network security. Those are available from our website if you'd like. We protect endpoints with SSL. We allow you to run encrypted file systems if you'd like. And we have a number of access control facilities, including something called IAM, Identity and Access Management, to give you fine-grained control of access. Each of your EC2 instances is protected by a stateful firewall called a security group. And we also give you control of the way that EC2 instances are isolated from each other. We also give you the ability to create what's called a virtual private cloud, or VPC. And a VPC is an isolated section of the AWS network that you can create this, you can assign your own IP address range, and you can then set up a encrypted VPN connection from your corporate network up to your virtual private cloud. Within that virtual private cloud, you have full control of networking, subnets, IP addresses, access control lists, and access to each of the subnets. So all these details are available on our website, and if you'd like to learn more, please feel free to get in touch with us afterward. We'll send you additional information about our security. And with that, let's go over to our main panelist, Harish.
Hey, thanks, Jeff. Thanks for setting the context and giving a very good overview into the capabilities of AWS. As Jeff pointed out, e-commerce is a very exciting and a fast-growing space. It gets even more interesting when you bring AWS into the equation, and that's what I would like to do today. So first up, I would want to highlight some of the key IT challenges that executives manage in the e-commerce applications are facing today. The first challenge is the utilization of your IT capacity in normal times. The second challenge is scaling and planning your capacity during peak times. The third challenge, what happens when the demands exceed my forecast. The fourth challenge is the lead time for procuring IT and trying to keep the costs low. After all, retail is mostly a high volume and low margin game. We will get into little more details of each and every challenge. This slide illustrates the capacity utilization of a retail website during a typical week. We see that it's full of spikes and valleys. We can also observe that less than 60% of capacity is utilized to serve the online customers, and 40% of capacity is underutilized. The question is, can we optimize the resource usage? Now moving to the second challenge, which is scaling and capacity planning for Thanksgiving and holiday season. Usually e-commerce companies tend to provision 15 to 30% more capacity than their forecast during the holiday season. This causes over-provisioning and underutilization of resources. Can we control this over-provisioning and align our infrastructure to traffic demands? Okay. Now moving to the third challenge, which is unexpected demand surge during the Thanksgiving. What if the traffic demand exceeds our infrastructure capacity during the holiday season? It will either lead to availability problems or slow performance. Customers tend to visit competitor site and it is a huge loss for the company. Can we avoid this? Now moving to the fourth challenge, which is lead times for leasing, procurement and commissioning. Procurement of an on-premise hardware takes at least a month or two. Leasing takes about 2 to 4 weeks, and deploying it may take more depending upon the complexity of the architecture. Nearly 70% of the IT infrastructure team's efforts are spent on heavy lifting activities like planning, procuring, and commissioning of hardware, networks during the peak seasons. Only 30% of time is spent on infrastructure issues related to value creation. So the IT team has to plan capacity with proper traffic forecast in advance, or be ready to be covered on the front page of newspapers. Is there a better way to address this problem? So these 4 challenges translates into following questions for e-commerce IT. How to address unpredictable scalability? How to ensure application is highly available during the holiday season? How to maintain performance levels of my app during the peak season? And how to optimize costs? The solution is Amazon Web Services. We can solve scalability challenges using Amazon Autoscaling feature, the high availability issues using multiple availability zones and AWS building blocks. Performance problems could be solved using CDN, ELB, caching, and database optimizations and tuning. Cost control can be done by pay-for-use model. Let's see in detail how AWS can address these challenges and questions. Meeting scalability demands using Amazon Autoscaling. So what is Amazon Autoscaling? Amazon Autoscaling is a service that helps us to scale out Amazon EC2 instances seamlessly when demand increases, scale down unwanted Amazon EC2 instances automatically when demand subsides. The scale-out increments can be as low as a single EC2 server. We can decide the scaling based on the actual CloudWatch monitoring metrics of the infrastructure, which is present in the gray box here. We can configure policies for triggering capacity up and down. The EC2 instances launched on the web and application tiers present inside the green box can be automatically attached to the Elastic Load Balancer. So what is the role of an Amazon Elastic Load Balancer in this diagram? Amazon Elastic Load Balancer is a web service which automatically distributes incoming application traffic across multiple EC2 instances. So Elastic Load Balancing scales its request handling capacity in response to incoming application traffic. So what do we achieve by introducing Amazon Autoscaling into our architecture? On the top diagram, we see typical traditional scaling methodology and its effects on the e-commerce infrastructure. The capacity is commissioned 1 to 2 months before the holiday period. This may lead to underutilization of resources or over provisioning of resources, or not able to meet the scenarios at all. It's all because the capacity is fixed. in the traditional scaling methodology. And this methodology can result in cost leakages and revenue loss as well. On the bottom diagram, we see Amazon Autoscaling and its effects on the e-commerce infrastructure. The capacity closely aligns with traffic demand, and hence results are better cost control and no revenue loss because of lost customers. So let's summarize the benefits of having Amazon Autoscaling in an e-commerce application. We can dynamically scale fleet of EC2 instances. The website traffic spikes can be handled with ease. We can drive scaling from actual metrics from the monitoring. We can have predefined scaling activities, periodic or one time for any special promotions. Next, let's see how to design highly available e-commerce applications in AWS. First point to design highly available application is to leverage Amazon's availability zones, popularly called as AZs. So what are Amazon availability zones? They are distinct physical locations having low latency network connectivity between them inside the same region. They have independent power, cooling, network, and security systems. The diagram shows Amazon availability zones represented as ABC in red squares. They are available in 5 regions around the world. So let's see how to leverage availability zones for high availability in an e-commerce application. Always partition the application stacks across 2 or more availability zones inside a region. This includes the web, application, search, caching, and database layers. Configure autoscaling to launch EC2 instances across multiple availability zones automatically. Configure Amazon RDS in a multi-AZ mode. This will run the DB master and hot standby in multiple availability zones. For read-heavy databases, have read replicas partitioned across 2 availability zones. Use AWS building blocks like S3, CloudWatch for monitoring SimpleDB in your e-commerce app. They can be accessed from multiple availability zones. AWS infrastructure provides certain building blocks which are inherently fault tolerant and scalable. Usage of these building blocks inside application architecture is highly recommended wherever appropriate. In this slide, let's see how we can leverage some of the AWS building blocks in an e-commerce app. The first one is an Amazon Simple Storage Service, popularly known as S3. It can be used to store web layer assets, log files, application backups, DB snapshots, etc. Amazon CloudFront for delivery of static and streaming content using global network of edge locations. We can use Amazon CloudWatch to monitor the AWS resources like EC2 instances, elastic load balancers. Amazon SimpleDB is a scalable non-relational data store. E-commerce modules like catalogs, shopping carts, where high availability is critical, can use Amazon SimpleDB as their alternate data store. Whereas modules like inventory, order management, or payments, where consistency is of highest importance, they can still use the traditional database EC2 instances or the relational database service from Amazon. SQS, SNS, and SES are messaging services that can be used to solve lots of complex messaging problems, and also helps you to loosely couple your e-commerce system. Performance is directly related to revenue, and a lot of business is lost because of slow response during the holiday season. We all know that poor web experiences impacts revenue, brand, and loyalty. So let's see how we can address this challenge in AWS. First step is to introduce content delivery network into your e-commerce architecture. Amazon CloudFront is a service for static and streaming content delivery. We can use Amazon CloudFront to distribute content with low latency and high data transfer speeds. CloudFront supports HTTP, HTTPS, and RTMP protocol. The content origin could be Amazon S3 bucket, Amazon EC2 instance, or this could be your own origin server also. E-commerce websites can have their web assets like images, CSS, and videos delivered through CloudFront. And CloudFront can be best used on the following e-commerce functions like catalogs, search, product displays, shopping carts, where performance and low latency is critical. This slide illustrates the Amazon CloudFront and Route 53 locations distributed across the globe. AWS is adding more locations to this list to serve content faster. Another way we can improve performance is to use Amazon Elastic Load Balancer optimally. So Amazon Elastic Load Balancer is a web service which automatically distributes incoming application traffic across multiple EC2 instances. It can automatically scale its request handling capacity in response to the incoming application. But ELB does not ramp up rapidly during sudden surge in traffic. It is advised to pre-warm your ELB for the big day. Another performance improvement that we can do is have SSL certificates installed on the ELB instead of the web servers. This will offload precious CPU cycles from your web servers. Another area where we can improve the website performance is caching. Functions like user preferences, product details, reviews are some candidates that can be delivered from cache. Amazon Web Services has introduced Amazon ElastiCache today. It supports version 1.4.5 of Memcached. Each ElastiCache node can have cache sizes ranging from 6 to 67 GB, and it is highly effective. The other popular option is using Memcached and Membase clusters for caching in AWS. Database performance. This is the most critical and key layer in an e-commerce application. Now let's see what are the options in AWS. Amazon RDS is a relational database service which currently supports MySQL and Oracle database. You can add multiple read slaves to RDS master dynamically in Amazon. RDS master and slaves replicate data between them asynchronously. E-commerce applications with read-heavy database workloads can use this architecture to improve their overall read performance. Some of the read loads can be distributed to alternate data stores like Amazon SimpleDB, MongoDB, and ElastiCache servers depending upon the use case. You can scale up the compute and memory resources of your RDS with ease. Additional storage can be added on the fly in RDS with zero downtime when our storage requirements grow, as well as the compute resources can be scaled up in RDS within a couple of minutes. When your e-commerce application grows in terms of user base, and traffic volumes, you can shard the database or RDS in AWS infrastructure. This will improve the overall read and write performance. Also, database EC2 instances configured with multiple EBS disks in RAID mode increases the performance. Next point is about cost control by using AWS. With AWS, you can keep costs low, move from CapEx to OpEx model, scale on demand with no upfront commitments. So this slide illustrates the potential cost savings for a typical mid-sized online retailer. So what we have done is we have taken a mid-sized retailer, and we have taken the number of servers that he would run on a normal season. During the holiday season, when he is going to peak up with 4x to 6x capacity, we have added nearly 50 servers to his normal traffic. So the same, we equated the cost with Amazon using extra large instances. So during the holiday season, it could be that 18 hours there would be peak traffic, whereas 6 hours of normal traffic. Using traditional hosting, we cannot scale down our infrastructure during these normal hours. And also, when the load increases, we cannot scale up or scale out using the traditional. Given the above comparative cost in running the service, so we see that nearly 64% of savings could be achieved by moving the infrastructure to AWS. So let's see some of the AWS use cases for an e-commerce application. So first one, run your entire application on AWS, so which is what we have been discussing in this presentation till now. The second one is run AWS as your extended data center. I'll pull up a slide to show you this use case. Okay, this slide illustrates how you can use AWS infrastructure as an extension to your existing data center. The first part is the connectivity. E-commerce app deployed in AWS can communicate to your existing data center using web services like SOAP, REST, and JSON protocols. It can connect to your data center using traditional FTP, SFTP, or SSH protocols, or use Amazon VPC, which provisions a private isolated cloud in the Amazon and offers a secure connectivity to your existing data center. These flexible connectivity options enable us to keep some client-facing modules of the e-commerce site in AWS, which requires high availability and scaling, and keep the others in existing data center. So we see like we can have our content, search, catalog, social apps delivered from AWS infrastructure. We can keep our inventory, order management, and payment in your existing data center. And we can move or migrate the systems in phases to AWS. The other things are we can just keep the browse-only side or test dev or configuration management aspects of the application in the AWS infrastructure. So coming back to the third use case, AWS can be run as a primary site, and the existing data center can be run as a disaster recovery. So the existing data center should be running in hot standby mode in case if you want seamless transfer. The fourth one is using AWS for disaster recovery, the AWS infrastructure could be used as cold, warm, or hot DR, depending upon the recovery point and recovery time objective. So what are the benefits AWS offers to e-commerce IT? You can scale the capacity on demand, derive value from good architecture. There is no fear of lost sales or because of slow load times or the server being unavailable. You can focus on the product and business, not on the servers. You can turn fixed costs into variable costs, and overall it is very cost effective also. So to summarize what we have seen, AWS is the right fit for e-commerce applications because they can optimize your normal times. They can optimize the cost during the normal times. You can align your IT infrastructure with the demand. You can scale up, scale out, and scale down depending upon the traffic. You can have multiple approaches and use cases to leverage AWS in addition to your existing IT. And it is very cost effective. And architecture is very critical in leveraging AWS. So what we feel is the time to get started for this season is now. Okay. So now let me show you a short video on Amazon Autoscaling. Okay, so let's imagine that this is the Thanksgiving and holiday season, and we have set up the servers in Amazon, and let's see how the Amazon behaves, the auto-scaling part of Amazon behaves during the peak traffic on the Thanksgiving day. So I'm starting the video. So initially we have 3 servers just satisfying the normal traffic, and we are pumping in a low and a medium load, and you can see that the transactions are happening, and the current server count that's running on Amazon is 3. So now you see the CPU starts increasing. We have set up auto scaling policies saying that if the CPU touches 80% and it remains at 80% for 3 minutes, then starts new servers on Amazon. So new servers are spawned since the CPU level has breached. So you can see that the server counts have increased to 7. So this is the typical scale out that happens during the Thanksgiving. So your servers are now at the level of 3 and it has reached 7. So now the load has stopped, or the load has started decreasing, and the server capacity is coming down automatically. And let's imagine now that the load is coming from the US West region. So we can see that the Amazon Autoscaling has increased the server capacity to 11 automatically. So initially it was serving the load from US East, and when the load has increased from the US West, the server capacities have started increasing from 7 to 11. So now the peak activity is over and the server load is coming down. So you can see on the graph, the load to the servers are cut down. The CPU is coming down. The overall CPU of the Autoscaling group has come down. So now we have set up a scaling scale down policy that once the CPU reaches a specific lower threshold and it remains on the lower threshold for a certain period of time, scale down the servers automatically. So this is a typical condition that happens during the nights, like Thanksgiving or other days, like when the peak activity is touched and when the peak activity is gone and the normal activity returns. So this happens to the CPU. So the server count starts dropping automatically. It has become 9. You can see on the right that the CPU lower threshold has reached and the overall CPU is coming down. So the servers are getting dropped. From 11 it has become 5 and back to 3. So overall, if you see, what we have seen in this demo is just a simulation of the Thanksgiving. When the load comes from US East, the server starts increasing from 3 to 5, 5 to 7, and when the load starts coming from US West, it got increased to 11. And when the peak activity is over and the normal loads return to, the CPU, the threshold has come to the lower level, because of which the auto scaling automatically cuts down the servers and it has come down from 11 to 7 and back to 5 and now to 3. So this aligns your infrastructure closely with the demand. So instead of provisioning a fixed capacity, we are aligning now our infrastructure closely to the demand. So let me get back to the slide. So 8K miles. So we are an Amazon Web Services partner. We help companies leverage cloud computing. We have expertise across the entire suite of AWS products. We have a team of experts located in United States, India, and Singapore. We don't want to spend too much time talking about us. We can get to the QA. The filler slide has some contact info to reach us. I think we'll open the floor for questions now.
Thank you, Harish, and thank you, Jeff. It was really wonderful listening to both of you. We have got some questions coming in. We have got about 5 more minutes, so we will take a couple of questions for today's webinar, and the remaining questions we will answer them over email. One question is regarding the security. Is AWS PCI compliance restricted to US alone, or is it globally applicable? Jeff, do you want to take that?
Certainly. So my understanding is that the PCI compliance is global. The details of all these things are available in our security center. So perhaps we can distribute the URLs to the security center to all of the attendees afterward. So when you build a PCI compliant application, you need to work with what's called a qualifying service agent, or QSA, and we can connect you with ours, and then our QSA works with your QSA in order to exchange the details of the PCI situation.
All right. Okay. Thank you, Jeff. The other question is, if I am moving my e-commerce application from my current hosting service provider to Amazon Web Services, are there any code changes involved to move them? Harish, do you want to take that?
Thank you, Raghu, for the question. If we need to move the application from the traditional data center or the traditional on-premise to cloud, it depends upon how much we want to leverage cloud. So simple step is just moving the apps, moving the application to the Amazon cloud. So that is possible. Sometimes when you want to leverage the auto-scaling facility of Amazon, your app should be designed in such a way that it can handle scaling out, which is if your app should be distributed on multiple web app servers. So during scaling out, what happens is Amazon Autoscaling starts creating multiple web app servers. So the problem would be on the sessions. So if your web app sessions are stored in some common location, then your app can store referring to this common location. Second is, when autoscaling brings the system down, your app should be designed in such a way that it can cope up with when autoscaling brings the system down. So it should be designed for such fault tolerant. This is one. These are all certain minor modifications that we can do on the app, and this is done on any scalable app. Usually it is done on practice on any scalable app. Second is, if you want to leverage the Amazon building blocks, it's all exposed as web services, REST, SOAP services, which can be easily consumed. And depending upon what use case you want to leverage and how many web services you want to leverage, there might be some code changes. So the summary is, you can move your entire app to Amazon. That's one. Second, with minor modifications on code, you can leverage auto-scaling feature of Amazon if that's not built into your code already. Third is, if you want to tie up the Amazon services and use it more closely with your architecture, you can call the web services and use it.
Thank you, Harish. We are running short of time. We will take one final question. This is from Tariq. His question is, how does multiple availability zone work? Are there any interdependency between the availability zones? Jeff, do you want to take that?
Certainly. So what we've done is that in each of our regions, we have set up so that we have multiple availability zones. Each of these zones is effectively a separate data center, is actually the best way to think about it. And as such, they each have independent power, cooling, physical security, network connectivity, and network security. When you decide to launch your EC2 instances, we always recommend that when you're building a scalable application that you launch instances in at least 2 separate availability zones, and that you then use our Elastic Load Balancer to distribute traffic across those different instances in the different zones. We also recommend that you use the auto-scaling, as we've discussed and as we've demonstrated, to make sure that those instances are healthy and that they're up and running, and that if any of them become unreachable or if you have a problem with an instance, that you can use auto-scaling to automatically disable the problematic instance and launch a replacement for you. So the idea is you want to build an application such that you can always tolerate a momentary issue that might be affecting a single availability zone.
All right. Thank you, Jeff. With that, I would like to close this webinar. Thanks everyone for joining us today. If you do have any further questions, please do reach out to us. We'll be in touch with you, and we look forward to seeing you in another webinar. Thanks everyone, and have a good day.